Okay, question number 10. Probably this was the question where I think the most points were missed as a class. So I'm looking forward to this being a great opportunity the next time we take a test. I think you guys will do much better thinking about these. So let's go ahead and start with the given triangle, right? It says triangle ABC and it gives the coordinates of A, B, and C. So I'm just going to go ahead and quickly sketch those. For A, x is 1 and y is 2. So there's my original A. For B, x is 5 and y is 4. So here is the original point B. And then for C, x is 4 and y is the number 1. So this is the original value C. So I went ahead and connected those vertices, and I have my original triangle ABC. Now, there's several things that are going to happen with triangle ABC. And the first thing I read, it says rotate triangle ABC 90 degrees counterclockwise about the origin. And then it says what are the coordinates of the resulting triangle A prime, B prime, C prime. So it's going to move, and we're going to rotate this whole thing 90 degrees about the origin. So this is the center of my rotation, and it is going to go counterclockwise. Oops. It is going to go counterclockwise, so the whole thing's going to be going this direction, and it's going to rotate through 90 degrees. Well, a lot of you, were using small scraps of paper. I did have some patty paper, but not a lot. I did buy a whole box of it, so definitely I will have that available in future testing situations if you want it. But we've been doing as a class a lot of these problems, and over time I'm starting to get the hang of where these values go. So I'm going to use the green, and A ends up going actually to the point -2, +1. Now, I want to try and make the case for what's happened here, right? You can see the coordinates of A as it was. A was at 1, 2, and I'm claiming that A is going to go to -2, comma, +1. So just kind of look at these and think about it. This is a counterclockwise rotation about the origin. The one thing that I notice, and I'll draw this and probably erase it, is if I look at this particular line drawn back to the origin, and I look at this particular line drawn to this point I'm proposing, those lines are perpendicular to each other because their slopes are opposite reciprocals. You can see one of them has a slope of down 1 over 2. The other one has a slope triangle of up 2 over 1. So I know, right, because I understand how these rotation works, and I understand 90-degree angles and the fact that their slopes have to be opposite reciprocals. So thinking about that, I'm changing the sign of one of these numbers, and the x and y values are switching places. So I just kind of need to be kind of aware of it and kind of use that to help guide me. So let me go ahead and erase these slope triangles and see if I can figure out the rest of the points doing something similar. Oh, I erased part of the A there. So back to the green. So C, you can see, is at 4, 1. And I believe that C is going to have to go to -1, +4. -1, +4. So this point right here is going to be my C prime. Oh, by the way, down here was the point A prime. Now I'm going to make another similar argument like I did with the last one. If I look at this, you can see if this is a line that I'm looking at the slope of that line, that's a slope that's up 1 over 4. And this line has a slope that's down 4 over 1. And you can see, yeah, when you draw, it's really convincing that those are indeed perpendicular to each other. So part of it is switching x and y, but then it's getting the signs correct, right? One of them has to change signs. And I think I've got the right value there. The last value here is b, and you can see b is at 5, 4. So I'm going to be switching them. I know 4 and 5 are going to switch places. And what's going to happen is I'm going to be looking at -4 for x. So actually, in every single one of these, from where it was at in quadrant 1, all the x values became the negatives. Let's go ahead and plot this point C. C is going to be at -4. Uh, I'm sorry. Uh, I'm doing B right now. It's going to be -4 and then +5, which is actually right here. Okay, so I can read these now. I can see the points here. Let me go ahead and draw the lines that connect them. And let's go ahead and zoom out a little bit here and write down these coordinates. So my answer so far is that A is at -2, +1, and B ends up being at -4, +5, and C has moved to, let's see, C prime would be at -1, +4. Okay, let's go on to question B. B says translate triangle A prime, B prime, C prime using this given rule here. So again, it's a little tough because if we didn't quite get the transformation correct for part A, we're going to have a difficult time getting B correct. So if you let's take a look at this rule, what it says here, it says that we're going to take our x, y's, and our x values, we're going to increase by the number 5. X's are going to increase by 5, and y values are going to decrease by 6. So I'm just increasing x by 5, decreasing y's by 6 for each of these points. So I'm going to go ahead and use, I guess I'll grab this kind of purpley color, and let's go ahead and take each of these. So let's take A prime first. A, I'm going to increase x by 5, so I'm going to go 1, 2, 3, 4, 5, and then decrease by 6. 1, 2, 3, 4, 5, and 6. So this point right here is now a double prime because I've given it this transformation. I've increased x by 5 and decreased y's by 6. Let's do the same thing for C. 1, 2, 3, 4, 5, and then let's go down 1, 2, 3, 4, 5, 6. And one of the things I like to do is, this is C double prime, is if you'll notice before from A to C, it had up 3 over 1. And I've got that exact same pattern going here, up 3 over 1. So these are exactly the same orientation, which is important because we're actually doing a translation. When you translate, we're not changing the orientation at all. Whoops, I erased my green line. The last point I need to move over is B prime. And same exact pattern, right? I'm going to go over 1, 2, 3, 4, 5, and then down 1, 2, 3, 4, 5, and 6. So this is now the point B double prime. Let me go ahead and draw those lines. Okay, so I think I'm ready to answer question B. Let me look at question B again. It says, what are the coordinates of C double prime after this translation? So when I look at C double prime, I can see that it has an x value that's right here. It has an x value that's equal to 4, and it has a y value that's equal to -2. So this is definitely at 4, -2. Let me write this over here in the important spot. 4, -2. And then our last question, question C here, reflect triangle A double prime, B double prime, C double prime across the line x equals -2 to produce a new triangle, ABC, that are all triple primes. The question here is what's going to be the coordinates of A triple prime? So first of all, let's talk about this line, the line x equals -2. And I'm going to go ahead and sketch where that line is at. It's right here on this line that I'm drawing, this little dashed line. All the x values are equal to 2. Anytime I want to draw a vertical line like that, it's always going to be an equation of the form x equals -2. The slope of this line is undefined. So when you have to have a vertical line that has an undefined slope, it has to be written in the form of x equals, and in this case, x equals -2. So if I look at this, if I'm reflecting across that line, I'm going to go ahead and use this kind of burgundy color. I know that the distances, 1, 2, 3, across the line of reflection have to be equal. So this is going to be actually 1, 2, and 3. This point right here is B triple prime. If I look at A is 1, 2, 3, 4, 5 across. So I'm going to go 1, 2, 3, 4, 5 away from that line of reflection. And this should be A triple prime. And then the last one is C, which is 2 plus 1, 2, 3, and 4. So that's 6 away. So I'm going to have to go 1, 2, 3, 4, 5, 6 away right here. So this should be C triple prime. Let me draw those lines. There we go. And you can just see visually that definitely this is clearly a reflection across this line. This whole shape, the A double prime, B double prime, C double prime, is reflected across that line, and the resulting triangle is the one over here with the triple primes. The last question here is, what are the coordinates of A triple prime? So if I'm looking at A triple prime correctly, it looks like it's at the point -7, -5. So let me go ahead and write this here. This point is at -7, comma, -5. And that's it for question 10.